Hi there, welcome back. Welcome back to another video in the restoration series for the SABA Breisgau 8. The last time I left off, I'd done the audio section. I did an interval there with a buffer for the visual analyzer software, which I'd found I needed when I did that testing of the audio stage. But back to the radio itself. I went on, as I usually do, from the AF section, from the audio. I went then back into the radio sections. Now the radio sections in this case, I work the two separately, the AM and the FM separately. Obviously there is sort of an interlink, especially in the IF stages. But with the AM sections, I found, strangely enough, very few components needed changing. We can look at that schematic and I'll show you exactly what was done. Here we have the schematic for the radio so far, and as you can see, quite a lot has been painted in here. If we go in a bit closer, a lot of this was already done before, as you may remember, but I went quite a few steps further. And if you look at this here, there's nothing that was changed. It was all checked, and everything checks fine. And then of course I got to this front end here. I didn't actually check these components. I wanted to, there were no capacitors that needed changing here. Some parts here were easy to reach, so I did test them. That was one capacitor I swapped out. I think this is actually the AGC cap, if I'm not mistaken. Maybe. No, I'm not. It is the AGC cap. But everything was checked here. Now, you might think, well, what the hell do I waste time on this for? Well, as you can imagine, when you're going through this and you're basically testing continuity and component values, it gives you a unique opportunity to understand the schematic. And that's the most important part for me. Then obviously I can almost guess that a lot of these components will be fine. And if they're not, then I could troubleshoot later. But it helps me to basically go through everything and understand how it works. It also gives me an opportunity to clean up switches like that there. So you might not be doing much in terms of component changing, but you do clean switches. You might have noticed I reverted back to the Meersburg schematic and just made a note of the differences, because this schematic is a lot cleaner than the Breisgau one. And so I decided to go back on here. So far everything seems to be exactly the same. This Meersburg schematic corresponds pretty accurately now to what I've been measuring. And let's just basically go through this quickly and see the differences. We've got the front end here. There are a lot of little things like the filter, the antenna filter. This is the IF trap over here. It's quite a bit more complex, more complete than we are used to seeing on some of the cheaper radios. But we've got another thing which is quite interesting, and that is there are switches everywhere. Like here, for example, that switch there, if you look at what it does, we've got the antenna signal coming down here, and it goes through here, and it then either switches to ground or it switches through to there. Now, what is that all about? Well, it means that the ferrite antenna is switched in or out. And the way it works is you actually rotate the ferrite antenna. You can angle it to wherever you want. And when you get to the extremes, to the ends, it actually switches out. It shorts the external antenna, or it brings in the external antenna, or it shorts it out, depending on whether you want to use the ferrite antenna or not. And again, there's another one here. This is probably switch 4. Switch 4, is that switch 4? Yeah, it's another one. That'll switch circuits in or out, because now you're bringing the antenna circuit through. So basically, the switching that occurs on that antenna block, which there are about 3 switches there, it lets you use either the ferrite antenna or the external wire, or in this case, the mini whip. So that's switched in. There are a lot of little switches like that everywhere. The other thing I've noticed, and I remember this from the Freiburg restoration that I did, there are these marks here, these points. This is R. Let's see, where else? There's P. We go up here, there's a few. There's Z, there's D. There are a lot of points marked like that. And what it is is this thing has got like a tube socket on the top, which is not a tube socket. It's for a test jig. If you look at the description, there's actually a alignment procedure for SABA radios. This is a general description that occurs at the end of the service manuals of most of these automatic receivers. There's German and English, and what they actually describe here is how this works. You've actually got a test jig which you can use on any of the SABA radios of that generation, and these points here, Y, D, X, Z, P, M, R, these are the socket points indicated here, the sockets, the pins of that socket. So what you would do is when a radio came in, you just plug in a test jig which is wired according to that pin out, and you'd be able to, you'd put your voltmeter, your VTVM, your high impedance voltmeter over here, and you'd be able to do, depending on what switching you use, you'd be able to do various tests, and you wouldn't need to go and connect things all over the place. Now you can do it anyway. This just makes it a lot easier. The other thing they have here, which you see, is here's a situation we've got 4.5 volts connected to ground. The positive is connected to ground, and the negative goes through a 1K resistor to point R. R is actually the AGC voltage. So I was right in saying that that was the AGC capacitor. So R is the AGC voltage, and it means that you are annulling it. You're setting a negative voltage, which is from a low impedance source like a battery or a power supply, and you are making sure that all your alignment that you do is not affected by the AGC or the AVC, because you are setting it at a fixed AGC voltage, which is minus 4.5 volts in this case. And again, things like that you normally wouldn't see in other radios. You can do exactly the same thing with other radios. You can use this idea perfectly well with other radios. You just go to the AGC cap and you put a battery or power supply on there. Make sure the orientation is right. Make sure it's negative voltage. And you'll make it more negative than little fluctuations would give. So in this case, they say 4.5 volts. But things like that you pick up as you go through the schematic. Here's the oscillator section. And again, the two ganged capacitor sections. And so you'd have the mixer oscillator here in the ECH81 as per usual. And that feeds through to your first IF stage, the first IF filter. This thing has got something slightly different, and I'm not quite sure why. If you look here, you've got L14. This is obviously the it's 250 picofarads, that's 50 picofarads. So this is obviously the AM section, and that's the FM section. So if we ignore the FM section for now, on the AM section we've got a primary, we've got one core that you adjust here, you've got 15, which is a core that you adjust here, which is a secondary, and then you've got another core in here, or another winding in here. And I'm not quite sure, I don't see anywhere where you need to adjust 16, L16. Now if you look at the others, same thing happens. L20 and L22 are secondary or different windings on this setup here. Now I do know that these IF transformers are very special with the SABAs. They have a coupling adjustment. They actually show you the build or the schematic of the actual interior of the core. And if you see here, what they describe is that you've got one core here, a primary. I'm not sure if this is a primary or a secondary. Here's another core. It's adjusted there and there. And then you've got a coupler. This D is the adjustment for the coupler. And it adjusts, alters the amount of coupling between that and that. So you can make the band pass flatter or sharper. And the way they tell you to do this is they tell you to not couple it critically. In other words, you've got to unwind this a bit and get it loosely coupled. Well, not really loosely, but not as critical as possible. Then you do the adjustment, you do the IF alignment of that core, and then what you do is you tighten this, and if you get more than 20% increase, then you got to realign this. So you couple it a bit more and you align it again. The idea is that you set this up so that these things are coupled at 20% from the maximum possible coupling that you can get. So we'll experiment with that when we do the alignment. It just means that you could make the band pass wider so you get more audio fidelity on the passband. You don't make it as selective although it is very selective, but you don't make it as selective. You make it a little bit more sort of frequency friendly, more bandpass, but we'll show that when we get to that. And going back to here, we've got basically the whole thing coming through to the point where at this point, using that, which tube? That tube there, the diodes on this tube, you've got your, hang on, which one is it? Which one is it? Yeah, that's the magic eye tube. But the diodes on this tube basically do the detecting of the AM, and that gets sent through here and it comes out. Where does it come out? The trick is to look for the volume pot. Actually, where are we? Oh yeah, here's the switch. This is between radio and, now this one here is between radio. We said that before, radio or pickup. So this is radio, so radio comes down here, and you have two options, either this side, which is this one here, which is the AM audio. That's it. Yeah, that goes through that diode there and it does your detecting, and your audio comes out here and goes to that point there. So, okay, what else do we have? So that's basically what I want to test today. I'm not going to do the alignment just yet because I'll tell you quite honestly what my problem is. I need to go and I need to check the FM section. I see quite a number, biggish number of electrolytic capacitors in here, and some more film caps that need changing, or rather paper caps that need changing. And I'm not sure how many of them are related to the FM. I haven't really looked. There are not that many. I know there's the ratio detector one here, obviously, but that's one. But there are a few more, and I need to make sure that they're not affecting too much over here of what I've checked. Certainly not in the circuits that I've checked. I know this has a lot of them as well, and this is that automatic tuning, basically AFC, automatic frequency control, which adjusts the motor. So there's a lot of capacitors in here that need changing. So I'm not going to go straight into aligning that because I need to make sure everything is working properly before I worry about alignment. But what I did find is a lot of the components on the AM section, and we can see that a lot of these components I've marked as okay. Things like this one here, C38, 4.7N. There's another one, 4.7N. These are sort of those dog bone caps, and they're bloody accurate. They hold their value very, very well. I don't think I've ever found one that was off. When I see one, I mark them as okay. Obviously, I could be wrong, but that's what we test for. Another thing I did is I did a lot of degreasing, and I say degreasing rather than lubrication because a lot of these, anything that moves on here was incredibly tied up. The grease they put on here had dried. It was like glue. The volume pot was one example where I couldn't turn it at all. The other one was this antenna, rotary tuner. This thing was completely, well, I could turn it, but it felt like I was going to break something. So in this particular case, I used WD-40, left it overnight, gave it some more the next morning, today, and it's now turning very, very well. But I want to show you a couple of the quirks here, and then the ones I've already spoken about, and then I want to talk to you. Well, we'll test this and see just whether it's receiving and how well it is. This thing here is the antenna rotator, and you can see that it actually does show you the orientation of the antenna. And I've got to tell you, it's not corresponding exactly to what I'm seeing on there, but it's pretty close. It gives you an indication of where you're pointing. So the idea is you could actually rotate this till you get the best possible signal wherever you are. And it works fairly well, except obviously we get very little on AM these days without the mini whip. So that doesn't do me much good. But there's one thing that happens when you get to the end. The first thing you see is that when it gets to the end, there's a switch that's activated there. And if I go the other way, there's another switch at the bottom, okay? Then of course the other thing it does is it rotates that guy. So you can see on the front where your antenna position is. I presume you would sort of fix a point and know that your station A or B or C is in a particular direction, and you'd set it there. But the other cool thing is this: when you see this rotate and it gets to the end, watch that switch. See that? That's the one that connects between the ferrite antenna selector and the external antenna, and it happens again on the other side. So this thing's got switches everywhere. And it's not just on the antenna that you have switches everywhere. You can see these end limit switches everywhere, like on the FM tuning. There's all sorts of switches all over the place. They're on the schematic, and sometimes takes a bit a bit of thinking to figure out what it is they're doing, but it all makes sense. So as I said, this is not looking like much has been done since last time. A lot of these caps were already replaced in the audio section, and you can still see a lot of those blue ones that need changing. Some of there's another couple of film caps down there that need changing. So again, I went through this very carefully. Some of the positions are difficult to reach. You just have to be patient. Sometimes you can't see where you're supposed to measure, so you follow the circuit somewhere else and try and pick up that signal somewhere else, or that point. But again, things like these tone pots were cleaned out. Here we've got another one. And the volume pot had already been cleaned out, and all these switches were cleaned out because some of them were sticking. A couple of the light bulbs, there are quite a few light bulbs. There's one there, that's for the music and speech indicator. Where's the other one? There's another one there. So depending on what you select, whether it's music or speech, the light comes on. A light comes on when the ferrite antenna is in use or not. There's quite a lot of indication going on, and we figure that out as we start using it. So I'm going to turn this around. I'm going to connect up the mini whip, and we'll see if we can get anything on AM. Let's put it on. As you can see, I made sure some of the lights were changed. Some of them were not working too well. At the moment we're seeing this one here, which means music is activated. If I do that one, that light goes on and that one goes off, so speech is activated. You'll notice this has got a light underneath. Some of them do not switch on. I've got the mini whip antenna on, and I've got the external speaker, which is a little bit distant from the microphone, but we should be able to hear it. Long wave at the moment, so let's see. Oh. Okay, see that? That was the ferrite antenna that was on. That's why we weren't getting anything. But you can see that, you can hear that it changes. Now if I go to the end, okay, one thing that's happening is, although the tubes for the motor control are not in, I can still feel resistance when I tune. In other words, the motor control is trying to do something. Now, I think I can, where is it, this one? I think that's made it manual. It's that way on my Freiburg. So let's see what we get. Actually, it seems stiffer. No, it's not. There's our beacon. See if there's anything else on Longwave. This is mid-afternoon, so there shouldn't be anything really. Well, we're getting something. This is amazing. This thing's coming from, I don't know where, but the quality of sound that I'm getting, and this is because of the mini whip antenna, is incredible. I can't play it for long because of copyright, but it's like this. You get nothing. Like, watch this. You can hear it, if I take the long wire, the mini whip out and use the ferrite, wherever I direct it, I get absolutely nothing. Okay, let's try medium wave. This is Canary Islands. I'm going to try the trick with the antenna again. Let's see what happens. No, can't reach it.
Electorales que sean un espacio para normalidad aún así.
This is the afternoon. Amazing. This is the local station. Let's try the antenna again. No, the ferrite antenna Madeira is just useless. Shortwave.
Especialmente el 50% de los fallecimientos se han producido.
Pretty busy. Okay. Right. Switch that off. So what we're seeing is that this thing is actually picking up pretty well. It has not been aligned at all. I've done nothing to the alignment. The tubes are the same ones that were here. Obviously tube sockets were cleaned and tubes were cleaned and everything else, but they are the original tubes. Some of the light bulbs were burnt out. I replaced those. Cleaned contacts, cleaned switches. Some of them are still getting stuck. So that needs another go around. But all in good time. So this thing is coming out as I expected. And as I said, this is the second one that I've done of this sort, the full automatic. The first one was the Freiburg 8, which is sitting here on my left and gets used a lot. This one is coming out the same, and it's great. Now, I'm still curious about the automatic. I don't know if it's working. I'm not sure whether this thing is actually taking it out of gear, as it were. Still feels a bit stiff, like it's almost like the motor is fighting me when I'm tuning. So I don't want to force it too much, because without everything working properly, I could do some damage. I don't want to do that. But what else can I say about the AM? Well, nothing much. It's pretty rich. It's a very full sound, and the reason I put this on the workshop speakers rather than on that little speaker is precisely to see what the sound's like. The sound is very, very rich. It's probably got to do with the width of the passband on those IF transformers, which is quite big and adjustable with the coupling, as I mentioned. So this thing is proving to be what I expected it to be. It's a challenge. There are a lot of moving parts. There are a lot of switches. There are a lot of little lights everywhere. You've got to take it very slowly. This is not the sort of thing that I'd want to repair for someone, because it just takes an enormous amount of work, unless you've done it before often. But it takes an enormous amount of work to study it properly, to analyze it, to figure out what's what, and then go in, get stuck in and do your thing. If you do it too soon, and if you make mistakes, it just gives you a hell of a lot more work than you need to create. So yeah, okay, that's going to be the video for today. I'll carry on with the FM section. When I come back, hopefully it'll be to demonstrate a good working FM. Wishful thinking, but hey, got to be positive. And then we've still got the automatic, and we've got the alignment. And then we've got this sort of final challenge, which is actually got to do with voltages. I'm not sure what voltages we're going to get out of here when I adjust or change that selenium rectifier. If you recall, selenium rectifier was left in there on purpose. So I'll be setting this whole thing up when everything is working and drawing its maximum current. I want to see what happens when I replace this with diodes. It's fairly easy to do, but it does give you an upshoot. It does sort of shoot up the voltage, because the voltage drop across a silicon bridge rectifier is much lower than selenium rectifier. But there is an advantage here. I've noticed this transformer has got some space in here, quite a bit of space around the windings. So what I'm going to do, and I'll probably turn this into a little bit of a tutorial video, is, instead of putting a resistor in line to drop the voltage, because remember we've got two problems here. One is this thing is set for 220, and we've got about 235 over here. And the other thing is, this thing's going to give us a higher B+, because we won't have the selenium voltage drop. So there's two things I can do. One is I can put a dropping resistor, or I can drop the mains by doing a reverse winding on the transformer. And I've done it before. I've actually done it to get a small voltage to drive a Bluetooth system, but I haven't done it to drop the actual AC voltage. It's almost like create another winding so that instead of using a 220 volt winding, you'd use a 240 volt winding. Not difficult to do, but I've never done it, especially not on video. So I'm going to try that. It can only be done if you've got enough space to wind wires around here. And this one is quite spacious here. You can see right through it, which makes it a lot easier. You can also do that if your heater voltage is too high. So again, it's a bit of a trade-off. You will change that, see what we get, and then we'll figure out what to do next. You can put that winding either as an additive or a reverse winding, either on the primary or the secondary. So there's quite a lot of options there. If you've done it before, you'll know what I'm talking about. If you haven't, stick around. We'll be covering that sometime soon. So that's it for now. I want to thank you for watching. I hope you've enjoyed that. If you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon. Once again, thanks for watching. Bye for now, and stay safe.